let's see if we can make our logistic regression model any better. So we've got these variables that we're going to be looking at, for better or worse. I've kept voicemail message and left off international charge. And so now we want to be able to evaluate whether we're improving the model or not. Let's, under options, select plots, default in additional plots, and just choose the ROC plot. That's going to be a little bit faster than making all of the plots each time. So we'll hit run and get our output for this base model, if you like. So a nice significant model. Got our ROC curve here, so an area under the curve of 0.82. It'd be great if we could get that a bit bigger. You know, if we could push this ROC curve out here, then we could select a model with a higher specificity and sensitivity. So now, how are we going to go about that? Well, our walled chi-squared value up here under the type 3 analysis of effects is actually really helpful. What it does is it tells us which of our variables seem to be the most important in our model. So where we see really high values for the walled chi-squared statistic, that's telling us these variables seem to be really important. Maybe we should investigate using them more to predict whether or not people are going to churn. So we're going to examine this through some polynomial modeling. We're going to add in polynomials for total charge and customer service call in order to see whether we should add in some sort of non-linear type effects. So to do that, we'll go to Model, Main Effects Model, nope, not and all in-way interactions, Custom Model is what we want. So now let's add in all of those variables. And we'll do polynomials with voicemail message, squared term, and what was the other one? No, it wasn't voicemail message. What was it? It was total charge. There we go. Polynomial of order 2. Having trouble hitting the 2 key. And customer service calls. Polynomial order 2. Okay, so we'll add those in. Click OK. And run our model. You might ask, well, Paul, why didn't you use international plan as a polynomial? Well, because that's a dummy variable with values just 1 and 0. If we square those, we still get 1 and 0. So we can't use that for polynomials. Alright, let's see if we did anything useful here. Let's see, we've got total charge squared and customer service squared. Still have these big walled chi-squared values, very significant p-values. So it looks like we did a good thing. They're significant in our model. That looks like we did something useful. And then if we scroll down to our ROC curve, you may remember our area under the curve was about 0.82 before. Now we've got it all the way up to 0.87. That's a big improvement from adding these two quadratic terms. So looks like we've definitely improved our model here. Okay, well if squared terms are good, maybe cubic terms will be good. So let's add in for customer service calls the cubic term and total charge the cubic term. See if these are significant. Hopefully you remember our procedure here. Keep on adding in new terms, adding in higher order terms until the highest order term that we've added is not significant, at which point we go back to the highest order term that was significant. Okay, so what have we got? Customer service calls squared and total charge squared, cubed are both significant, and they're both significant in our model here. So again, it looks like we did a good thing. Did we improve the ROC curve? Yeah, we did again. It went up from 0.87 to 0.884. So not as big a jump as before, but still an improvement. Okay, if cubic terms are good, maybe quartic terms, fourth order terms are going to be good. Well, let's try. Customer service calls, fourth order term, total charge, fourth order term, okay, and run our model. So, was this a good thing to do? Oh, doesn't look like it. Customer service calls fourth order and total charge fourth order. Neither of them are significant. Both not significant there. What did it do to our area under the curve? It made it worse. It was 0.843, now it's 0.883. So we did a bad thing adding those fourth order terms. So we would want to delete both of those and go back to our cubic model and have this be the model that we're going to run with. In principle, we could go through and try and find some interactions as well, but I think we've done enough here. We've got a pretty nice looking area under the curve. I'm pretty happy with this model now.